Thank you. Yes, today I'd like to talk about Fellgate Surface Water Management Scheme, which has been recently completed in the North East. This was delivered in partnership, a partnership between Northumbrian Water and South Tyneside Council. And I think that was really made possible by the conversations and the relationships that Northumbrian Water made through their drainage strategies and the previous studies. And it meant really when the project team came along, the conversation that we had between Northumbrian Water and the local authority was really easy. Everybody was kind of geared up that this was the way that they wanted to do it. So it's a sustainable scheme. I think the main story here is about integration, an integrated approach. So we were integrated through delivering through the partnership. It was an integrated solution which satisfies both the sewer and the surface water issues. It's a solution that fits in with its environment. And there's a nice story about how we manage the data through the process in order to deliver that solution. So I guess the title of the presentation is an integrated approach to surface water management delivered a sustainable solution by developing a common understanding of the problem, sharing responsibility, and coming up with a common solution. It's about adding value through the amenity, biodiversity, the education, and all those wonderful things that SuDS create. And it's about engaging the community throughout the project to win support. So a little bit about Felgate. Felgate suffered significant flooding in 2012. It had a history of flooding, but in 2012 about 170 properties flooded quite severely. Flooding came from the sewer network, drainage ditches, the local water course, and surface water in general across the catchment. And the complaints kind of came through to either Northumbrian Water or to South Tyneside Council, or maybe both, but neither organisation really had a full picture of what was going on. So it became apparent early that it made sense to create this partnership to share information initially, and then work together to deliver a solution that fixed all the problems. And that kind of developed into a legal partnership agreement between the two organisations. And I think it fits really well with the DEFRA guidance, which is about working together and developing a shared understanding of the most suitable solutions to surface water flooding problems. So a little bit about the Felgate catchment. It's kind of an island catchment. It's a residential housing estate which is surrounded by this radial road running round, and there's farmland on three sides, and to the north there's a railway. It's a separate system, sewerage system, and there's a number of culverted water courses that run through the site. There are also a number of historic land drainage connections into the surface water network at the boundaries to the south. So it's quite a complex system. There's a water course to think about, there's surface water to think about around the surface, and there's the issues with the drainage network. So we used an integrated catchment model to model what was going on with the system and start to think about the solutions. And the solutions were phased, so we kind of went out in two phases, and the phasing kind of helped a little bit with the programme because it meant we could think about Northumbrian Water's issues and get running with it on the ground. And while it was being built, we were thinking about the surface water solutions and allowing South Tyneside to get time to get all their funding in place. But in terms of the public perception, they kind of saw this continuous work for the whole duration. The same contractor was on site, and it was the same site compound and things. The sewer network solution was really to fix some issues that were on the sewer network, collapses and things, and bring it up to the kind of 1 in 20, 1 in 30 year design standard, and to cut off the land drainage connections historically that were in the bottom of the coming in from the fields to the south, and these were picked up in 2 basins and directed off towards the river. In the second phase, then we started looking at the what was happening around the surface, and the measures that were put in place were bunds to protect properties, swales, and to intercept overland flow routes and to carry that flow through to detention basins where we could locally store surface water. The basins to the south, the design standard for our South Tyneside was now the 1 in 100 year, so the basins to the south needed to be bigger, but in reality they were built in phase 1, and there was a little bit of sharing of funding between the South Tyneside Council and Northumbrian Water to complete those. And the type of measures are really there to design, to intercept your overland flow routes and store in a suitable location on the surface. So the type of measures that you're thinking of, we're thinking about fairly large measures in order to pick up the 1 in 100 year storms. So if you think of kind of water quality and spill frequency SuDS, you might be looking at source control measures, which are going to strip out the sort of lower intensity rainfall. But here, really, you're on the bigger measures, large swales and regional storage, in order to capture the quite large flows, attenuate before you discharge, either back into the existing surface water network or to the watercourse. And from a design point of view, that presents some challenges for us. So we're now looking at flows sloshing around the surfaces. We've gone away from underground pipes and large storage tanks. So you have to think a little bit more about where the water's going, where it's coming from, where it's going to. And freeboard, maybe you don't have the luxury of the freeboard that you have between a below ground storage arrangement and above ground storage. And you need to think about what those measures are doing or how they're working in the environment. So unlike your conventional pipes and concrete storage, which is all below ground and nobody sees, now you've presented something on the surface that's going to be a permanent feature. And you have to think about how that affects the environment that it's in. So we need to involve another group of people. We need to think about the landscaping and the ecological side, and involve more people in how we put these together. So the design approach, we had to think a little bit differently maybe than what we would have done with a conventional solution, and we kind of set out to try and do it better than we had in the past. So, and there's a nice story with the data. So we started out and we collected our data in 3D. So we do 3D topo surveys. We collected utility surveys in 3D. We have LiDAR, and we bring that all together and we use that to create our integrated catchment model. And that model is there to help us understand the flooding mechanisms. And also, although we're kind of coming up with a holistic solution, we're still required to define whether who's responsible for the flooding. So you need to determine whether it's sewer flooding, which is a water company issue, or surface water flooding, which is a South Tyneside Council issue. And in order for those organisations to justify the funding, then you need to be sure that you've properly identified who's responsible for what bit. So we used an integrated catchment model to do that. We then brought our 3D information into a 3D design package. So we're starting to think of the designs, and we used Civil 3D for this, which has a lot of nice tools to help us form the SuDS features in the surface model. So you can grade, you can do cut and fill balances, and on one particular site in a school, we dug out for the SuDS measures, and then we used the excess material to create landscaping bunds, so you can come up with a zero cut and fill balance. And once we had our designs in place in our 3D model, then we needed to export that 3D model, bring it back into our integrated catchment model. And in this particular case, we were able to therefore run exactly, as far as we can get, what we designed in our catchment model, which I think it was tricky, but it's possible to do that. And up until this point, it doesn't really cost you anymore to do this. As long as you set out and collect all your data in the right format, you can go through the process pretty much the way that we were doing 2D, but there's a lot of other benefits. In the Civil 3D, you can do things like clash detection, so you can check how your pipes affecting other services and things that are below ground. And once you have this 3D model, then you can start to do really interesting things with it. So we created some visualizations. So the 3D model was brought into a gaming engine, and we were able to create walkthroughs and flyovers and things of the measures, which is a nice communication tool. So when you're going out to your community, instead of going out with your 2D technical drawings, you can start to think about the sort of visualizations that might be more appropriate for the general community. We can go into schools and show them the little gaming tools and things like that. And following that, we then were able to bring our contractor in and use the 3D model with machine control to form the basins. And I think at the outset, the contractor might have been a little bit nervous about using 3D for doing this. And on one particular site, he had planned in 5 weeks to do his grading of some of the SuDS measures, but with machine control, he was able to finish it in 4 days. So there were significant benefits from operating in this kind of 3D environment to the outcomes for the project. So the partnership brought a number of benefits. So firstly, I guess it opens up new tools, measures that the water company that can then use. So the things like SuDS, you can come up with agreements for things like land purchase. Maybe it's a little bit uncertain as to whether water companies have powers to buy land for SuDS, but partnering with the local authority solves some of those issues. Agreements such as or planning permissions and things like those, it's a much smoother process when you can kind of do that in partnership with the local authority. And if you think about adoption and maintenance, the water company has certain skills in and is lots of experience in maintaining sewer networks, maybe not so much in the kind of ground maintenance type activities that you might expect with SuDS. But a local authority have parklands, ponds, and are therefore probably in-house have the skill set that's required to maintain those sort of SuDS basins. So you can start to see how the partnership can start to share responsibility for building the SuDS, but also maintaining them and adopting them in the future. And then the other big one is funding. So you can start to see the benefits from having a single project with a single contractor and a single designer, and the savings that will bring, and the ability with working through the local authority and FCRM type funding that you can start to bring in other funding streams in order to give you your pot of money for putting in the process. So, and this is back to making sure that we're clear about who has responsibility for what bit. So we have one holistic solution, but we still understand that the water company is responsible for a certain amount of the cost and the flooding, and the local authority has a responsibility set out too. So there's lots of added value opportunities with SuDS. So we can plant wildflowers in the basins. We can put up bug hotels. Within 2 of the schools, we constructed ponds, and planting and landscaping within those areas. We created an outdoor classroom in the schools just to increase the benefits that they're getting from what's going in. And we also, through the SuDS for Schools initiative with Northumbrian Water, brought in the WWT to do little sessions with the school kids, and they went out and did some of the planting. So there's lots of really good benefits that come straight away from choosing to go down the SuDS route. And with those benefits, there must be value. So we also looked at how we can assess the added value and monetize those values in order to help our cost-benefit business case. So the flood risk benefits are quite straightforward. We can use the multicoloured manual to work out the costs of flooding at individual properties, and therefore work out the cost savings with putting in the measures. And then we can start to monetize the other intangible benefits, so things like habitat creation has a value, and we can do a benefits transfer approach. And this was done really through an early version of the Syria Best tool. And I think this is actually used as one of the case studies now for that tool. So the benefit really here is that at the time, the water company probably can't recognize the financial benefits of doing the other added value stuff, and that might have changed. That might change going forward, but certainly the local authority can recognize those benefits and use it in their cost benefit assessment for when they're going for their FCRM grant and aid funding. So really important, the community engagement aspect. So we've created things which are sitting on the surface and are going to be seen by people that are living around it. And I think at the outset, the noticeable benefits of using these SuDS measures was probably with the conventional solutions. You used to go into the school and you say, we're going to come in, we need to fix this flooding, we're going to be here for 6 months, we're going to tear up your field, there'll be loads of disruption, but don't worry, once we're finished, you'll never know we've been there. Now you can kind of go in and say, okay, we're going to be in, there's going to be disruption, but really what we'd like to do is create this nice pond or wildlife area. And I think immediately the conversations go away from the disruption and the negative aspects to the positive, to what the school is actually going to get from this. So the conversations become much easier. I think from the outset, Northumbrian Water and Southside Council were very keen on putting forward this one approach, and they had events with the joint events with the community to explain what was going on throughout the process. So everybody was well aware of what was going to happen and how it would impact them. Then they went into the schools with the WWT to talk about the water cycle and construction and things like that. And this kind of followed through into the construction where the contractor picked up that kind of liaison. The contractor also put in place things like the considerate constructors type initiatives, doing bin collections and watching out for special care customers, and planning works really around the community to minimise the impact as much as possible. There was a bus service put on around the works so that whenever roads were closed, all the residents still had access to the buses. And then there were these events with the schools themselves to go out and do the planting and things. So I think really the community engagement started from right at the beginning of the project before we were anywhere near site, and ran the whole cycle. And really the result of that was a very positive response from the community. And in terms of the basins themselves, well, they were tested probably January this year, when we had about 75 mil fell over a couple of days. Probably not the 1 in 100 year that the basins are designed for, but certainly it would have been enough to cause property flooding had the measures not been in place. And I think from a personal point of view, it's nice to create something that you can see from Google, and it isn't buried below a bit of poor reinstatement. So just to finish then, an integrated approach to surface water management delivered a sustainable solution by developing a common understanding of the problem, shared responsibility for the works, and an integrated solution, adding value through maximising the benefits that you get from the SuDS, and engaging with the community throughout, really, to win local support. Thank you.
Okay, a few questions. If I can perhaps kick one off. The partnership that's been talked about is very much between largely the local authority and Northumbrian Water in what I've seen in that particular scheme. What other partnership options do you think might have been available in other circumstances to actually deliver things with additional value?
Yeah, well, I guess the active partners were South Tyneside and Northumbrian Water, but then the FCRM money comes from the EA, so they're more of an inactive partner. They're providing funding to it, but they have limited interest in what's going on other than the funding mechanism, because it's not their rivers that are causing the problem.
Sure.
They're doing some sustainable drainage systems within their factory. We are contributing to enlarge those drainage systems, so we can get additional benefits and reduce further the amount of flows to the combined sewerage system, and therefore reduce flood risk downstream. So we are actively contributing to others rather than just these sustainable systems with ourselves and local authorities.
Chris, are the SuDS basins and swales designed for infiltration?
There was a lot of discussion about infiltration when we were, whether you should line the basins and things. I think what we concluded really was there was no need to line them. It wasn't a problem to have infiltration there, so we weren't there to prevent infiltration, and there was no need not to. But they're not designed for infiltration. Typically, they're clay soils, but you are going to get some infiltration. And I think probably the difference between the SuDS basins and kind of conventional drainage is you're probably a lot more keen to, get the precise volumes and things down on your conventional drainage, where it's costing you quite a lot of money to put in more concrete. Whereas these, once you're kind of on site and you're landscaping things, the volume's less of a concern. So, an extra 10% on the volume's not really a problem.
So have you done any monitoring to make sure, or to understand whether what you got in the model was actually what you're seeing? And feeding back?
There isn't monitoring in place at the minute. I think it has been discussed on other projects as to the questions asked. How do you know that they're doing what they're supposed to be doing? And probably there isn't an allowance in the project budgets to do that. It's probably something really that we need to go back to Northumbrian Water with and suggest it as another question is about things like the planting. It's going to take 5 years before the ponds are established and the wildflowers are in place. And do we want to go back out and just check that what we get is actually what we thought we were going to plan for in the future? So there's a few aspects of monitoring really that we could look at. And because it's sort of early stages for ourselves, Northumbrian Water and SuDS, it's probably that would be a good thing to do.
Renu Gunasekar from Arcadis Consulting. Christopher, just a couple of points. You mentioned that the 3D data, the data you gathered didn't need extra effort to incorporate. For example, I don't know. If you can elaborate a little bit more, sort of services and various information were they readily available in 3D format, for you to easily incorporate. And also elaborate a little bit more. You mentioned about construction, time saving because of the 3D model. The Arc 3D, the CAD 3D you had helped to sort of reduce the construction time scale. Elaborate how was that is achieved. That will be quite interesting, I thought.
Well, on the first point, from a CAD point of view, it's just makes sense to use 3D these days. The majority of our CAD staff are capable of doing it, and as soon as they've gone there, they won't go back. There must be nothing more tedious from a CAD point of view of drawing a long section through a pipe profile. So instead of drawing, what the CAD technicians are now doing is computer-aided design. So they're building a 3D model of the ground and of the below-ground network, and then from that they're extracting the drawings and things that they need. So that bit, I think, is available to everybody, and we should be using it. In terms of transfer of data from your Civil 3D model into your modeling package like InfoWorks, that's a little bit more of a problem. So you have a 3D ground model with 3D faces in Civil 3D, but actually what InfoWorks wants is a 2D mesh. So although you end up with lots of triangles, they're all flat. So one of the issues, for example, is that if we drew a 3D bond in Civil 3D and we export that to Civil 3D and put it into InfoWorks, and it flattens all the triangles, the bond's half as high as it needs to be. So you kind of had all these leaks popping up all over the place. So you have to do things like make sure you put in break lines in your 3D model in order that when you export to and use it in InfoWorks, it'll read that as a bond and put a nice triangle at the top where you need it. So there's lots of little issues like that become a problem. And also the volume of data. Civil 3D can't handle large data files. So you need to kind of simplify down the data that you've got, because we'll have a tendency of just getting LiDAR at half meter resolution and trying to squeeze that into a Civil 3D model, and then it falls over. So you need to sort of think about, well, do I really need half meter LiDAR in a field? Can I, live with 5 meter resolution, and therefore use the data that you need to create your model, so that you're then able to handle it in Civil 3D and then export it from Civil 3D to get it into InfoWorks. But you can't generally tell InfoWorks to use the same mesh. It wants to generate its own mesh. It's only referring into the 3D model.
Yeah. I mean, you finally, I think, the construction, I think, you mentioned, a little bit, time saving you achieved. The contractor managed to achieve some, time saving. How was that done? Is it easy to transport? Take the model into the construction equipment, and then you could sort of shape the profile easily, rather than setting out, and everything is much more efficient. Is that the way you did?
So they can use the 3D model without any. We had no need to convert it to anything. They used it as was, fed it into their GPS system on their machine control, and were able to use that to trim the basins. So. It also means that you get a better quality result, because when you've asked for a 1 in 4 slope that you've got a 1 in 4 slope, unlike when you turn up to site and say, I asked for a 1 in 4 slope, but that's not one. It's you do get a much better finished product for doing. But in order to use that, you probably need to spend a little bit more time on your 3D model. So because you want to have your grades and things in it at the bottom, which you might have left out and just put the little arrow saying lay at 1 in 200 or something in the past.
Thank you, Chris.